project for us began in the summer of 2001, so a long time ago now. Graham Stirk, one of the partners at Rogers Stirk Harbour, it's probably called Richard Rogers Partnership at the time, called and rather hesitantly said that they were doing a secretive competition for British land. 4 architects looking at this plot of land, really with quite an open brief about what's the potential for this site. It already had a 14-storey building here from the 1960s and was doing okay, but what could the potential be here was the question. So the phone call led to a meeting, and we began by talking through a whole range of engineering issues and planning issues about building large on this site. And very early on it became clear that the view along Fleet Street past St Paul's towards this site was quite critical, because a tall building on this site would appear in the background of St Paul's, and it needed to be careful, therefore, in how it sat in that background.
Early days, the collaboration between the various parties was incredible. To demolish a building whilst piling at the same time, and also getting the new construction of the foundations in whilst the final aspects of the core were being torn down, was amazing. And everyone worked together to make this thing happen. As part of the demolition of the existing building, which had a large central core that was right in the middle of the site, we developed, along with the demolition contractor McGee's, a system whereby they brought the central core down whilst we were building a donut slab, as we called it, which was a 3-metre thick slab around the perimeter of the site. That perimeter, that donut slab, served to hold back the adjoining buildings, whilst also allowing us to dig out in the middle of the site a new 4th level of basement. What we had to do was dig the 4th level of basement whilst not undermining the adjoining structures. One, the listed building next door to the west, and the basement structure of the Aviva Tower next door to the east. We're standing at the 3rd level of basement, which we call B3. Next door to us over there is the Lutyens buildings, and its foundations are probably about a story higher than we currently stand. If we walk over here, in the middle of the building, below us there's another level of basement, B4, and then below that is 3 metres of concrete, which forms the major part of the foundation, which is effectively another story's worth.
Well, I've been involved working on the lifts and escalators at the Leadenhall building for quite a number of years now. It's been exciting, challenging, sometimes frustrating. It's interesting that it requires such an international mix of people and manufacturers to actually produce the things that we see here today. So, for instance, the escalators started life being manufactured in China. They were then put into crates and containers and shipped to Yorkshire, where they were finished off before being brought back here to be finally assembled and installed by the English crew. And similarly, the lifts behind me, the orange main steel framework was actually manufactured in Germany. It was then shipped to Finland, where the rest of the car was added, and the whole thing shipped in a single piece to be installed here by, again, the English engineers. It's a little bit disappointing to me that so little of this work has actually been manufactured in the UK, as so much of our manufacturing industry has just declined and isn't there anymore. Most people wouldn't realise when they get into these lifts that the weight of the moving parts is about 22 tonnes and they're moving at 30 kilometres an hour. Now, when the lift comes down and gets to this floor, which is the lowest floor, it should stop. However, if it doesn't, we've now got a 22-tonne thing moving at 30 kilometres an hour that we do have to stop, and that's what these buffers are for, before it hits the bottom of the pit. On these ones, it's not too bad, there's nothing much underneath. However, on some of the lifts, we actually have a glass floor in the bottom of the pit, and people walking underneath it. So a 22-ton lump of metal landing on your head wouldn't be great. One of the tests that's most interesting is when the lifts are completely finished, they actually fill them up with 1.6 tons of weights and then run them all at full speed, having turned off all the safety circuits, so they do actually crash into the buffers to make sure that they work. It's always concerning. It's way more concerning when you actually have a lift that's made largely out of glass.
The opportunity to see the structure unimpeded is really what excited me about this project right from the beginning. It's kind of classic Richard Rogers style of architecture. You can take it right back to the Pompidou Centre or indeed the Lloyd's building right opposite. This celebration of the engineering. That's what the architects are into, and that was really what I was into. We were designing a structure which was completely external, completely around the outside of the building, and completely visible. And it was the fact that it was really visible that gave us the greatest challenges, because of course, once your structure is visible, it becomes a key part of the architecture. And it's got to not just do the job of a structure of holding everything up, it's actually got to look right architecturally, it's got to look coherent, it's got to look attractive. And actually, more than that, it's got to be clear how it's actually working. We were very conscious that in showing off the structure like this, we were actually creating a piece of structural engineering that people could enjoy, could appreciate and could understand. And so it was really important that we really thought about how it was working and made sure that the detailing of it reflected how it was working and made sense to people who looked at it. So I'm standing in the North Core, which is completely different. It's a completely different structural system from the mega frame. Of course, it's distinctly different because it's yellow, but actually the design of it is completely different as well. It's on a much smaller scale, much more intimate. And the steel tables of the North Core are also very unusual because before they came to site, they weren't just pieces of steel. They'd already had the services installed inside them. All the ducts and pipes which are above what you can see here, those were already there on the tables before they came to site, and so was the concrete slab that goes on top of it. Because of the shape of the building, because it's much taller on this side than on the other side, and because of the arrangement of the structure in it, it leaned sideways as it was built. We knew this was going to happen. We knew approximately how much it was going to move, but not exactly. And so we had to adjust it. We had to pull it back into position. And normally what you would do is you'd build it with the geometry set the other way and hope that it would move into the right position as it was built. This was different. What we did here was we built it straight and then we monitored how much it moved and then we pulled it back again after it had moved. So when the building was about halfway up, the structure was about halfway up, we started making adjustments near the bottom, and which were very carefully calculated to pull the building back into position. Normally on a steel building, the floor structure would be poured as wet concrete onto a steel decking system. That's the normal way. On this building, we did something completely different. Above level 5, we made it out of entirely solid precast concrete planks. It's the first time a building of this height has used solid precast planks, not even wet concrete on top of the planks. And you can see them here. You can see the soffit is molded. You can actually see the concrete soffit itself, whereas normally you'd be looking at a steel decking. It's not the most beautiful thing, but it's a molded piece of concrete. This made the construction process much more efficient. It meant that far fewer people were needed to assemble the structure on site, which made it safer and it made it quieter. It reduced the amount of waste associated with the construction process as well. And also it meant that as soon as the floor had been built, there was a surface that could be used for putting materials on for the next stage of the process.
We're standing at level 2, reception level, and behind me you can see the Galleria space. This is the lowest of the 8 megastories in the building. So above us are 50 stories of office. It's 28 metres from the floor down there up to the bottom of level 5. So a massive open space. It's about the same size as some of our neighbours on Leadenhall Street. We made 2 important structural moves to make this happen. The first was to find an alternative to the central concrete core. So for office buildings, they normally have a central core which provides stability. That means stopping the building overturning from wind loads. That's normally formed by using concrete walls around a lift shaft and stairs in the middle of the building. But for a tall office building, it can be quite extensive and it can take over the ground floor. So in the Leadenhall building, we did something different. We used the perimeter megaframe around the outside of the building to work like a big tube. And it moves the structure from the middle to the outside of the building, freeing up the galleria. The second structural strategy we had for avoiding columns in the galleria was to use hangers. So that means for levels 3, which you can see up here, instead of having columns underneath the edge of the slab, we use hangers to take the loads upwards rather than downwards. It means it's more open below, there's a lot more space for members of the public, and it's a very generous volume that we've given back. Over here you can see the arms that are reaching out from these last floor beams. They reach onto the bottom of the hanger, and the hanger, which is made out of steel, it's about 100 millimetres solid steel, carrying several hundred tons of force, carries those loads directly up to level 4. Level 4 we do exactly the same, and those loads go right up to level 5. Level 5 has got huge steel beams that take those loads back to the perimeter megaframe. The best thing about this space in the galleria is the fact that none of the structure is overclad. You reach out and touch it, and that's the bit of the structure that I designed. We look up there and we see the hangers. I remember the Thursday night at midnight when I drew that sketch for what that was going to look like, and now I can see it.
We're here on the 49th floor of the Leadenhall building. It's at the base of where the cooling towers are. Below us are 3 levels of plant room, and above us is the cooling tower level of the discharge, and above that there's a cooling cradle. So what we have here is plate heat exchangers, which are changing the chilled water from a condenser water system in the basement, convert it into an evaporative cooling system. In the steel boxes you've got a cooling medium, which is water, going through a large drop. And it allows fresh air from the outside of the building to come in and get drawn through the water, which evaporates. And that is the main cooling mechanism for the building. In a normal building, and particularly in a tower building, we try and get the building services to be located right at the top of the roof. Gives good access to air, which we need for cooling and air distribution. And we normally have the full width of the building into which to put the plant. And so typically ends up as about a 2-story plant room on top of a normal building. Now with the Leadenhall building, because it tapers right the way from the base, right the way up to the roof, we are losing a lot of floor area to put the plant. And as a result of that, we have to position the plant one on top of the other, and it actually becomes a 7-story building on top of the office space, which we've called the attic. And it is designed with a lot of input from the architects as well, because it's so visible from the rest of the streetscape. So a lot of the positioning of pipe work, duct work, and the rest has all been designed with the architects, so that it not only works in terms of functionality, but it also looks pleasing from the outside of the building. So we're now standing on the 43rd floor. It's a typical office floor. And we're next to the facade, which is extremely important in terms of limiting solar gain and also limiting heat loss. And as with a number of high performance buildings, the solution to this is to go for a triple glazed facade, in which we have the double glazing on the inside, a ventilated cavity, which is ventilated to the outside, and a single glazing outer facade. And essentially what this is doing is it's trapping the solar gain outside the building and making sure that the energy doesn't come back into the space. So here we can see the blinds being deployed. They're automatically controlled blinds for the whole space. They deploy both coming down and also tilting to allow a maximum views out, maximum daylight in, but also retaining the ability to keep the solar gain outside the space. We're in a typical floor plant room where we have designed the systems to separate the high pressure landlord systems and the tenant systems. This allows each tenant to operate in their own space, and particularly allows them to do changes, amendments, fit outs without affecting other tenants. And this is extremely important for the landlord because it means they don't have to worry about how one tenant may affect another tenant. For the tenants themselves, it's a very easy system for them to operate and maintain, at any time they like. I think initially our concerns were trying to get all of the plant onto the roof. It's clearly a very difficult task to create a plant room which looks good, but it's also a plant room which has got an enormous amount of power behind it. And this building is designed for about 7,000 people in their working lives, which is about the same size as a medium-sized town in the UK. And it is supplying everyone with their power, their water, their drainage. All parts of that are essentially a town in a very small city block.
I think working with such a fantastic team, the architects in particular had a great interest, much more so in the lifts on this building than you would on most, because they are a huge architectural feature on the building that really can't be missed. And they're also, of course, the fastest scenic lifts in the world.
Some of the buildings I've worked on, Merrill Lynch opposite the Old Bailey, Moore House on London Wall, Citibank headquarters at Canary Wharf, but by far and away the best building I've ever worked on is this building, 122 Leadenhall Street. It's been an absolutely amazing experience with an amazing team. A lot of hard work over nearly 10 years, and it's produced a fantastic display of engineering.
I feel so proud to be standing here now it's all finished. It's been a fantastic journey for us all. I've been on the job since 2011, so I was on it full time for about 3 years. I designed all the floor steel work, from the mezzanine right at the bottom to level 51 all the way up to the top. The best thing about this building though is it allows us to show off what we do as structural engineers.
I've worked on this building for 14 years. I started in 2001. I've spent about 5 years of my life working on this building, and it's been the most wonderful project for me. What I really love is designing structures that you can appreciate, that you can see, and so when I'm working with an architect who likes to show off the engineering, that's perfect as far as I'm concerned. And of course this building represents that at a scale that nobody's ever tried to do before. Nobody's ever tried to do architectural steelwork on a skyscraper. It's almost unthinkable, and yet that's what Rogers and we wanted to do, and the fact that it's all worked and it's been built and that the steelwork has been made so beautifully is just incredibly satisfying. I'm very proud of the project.
I think one of the interesting things coming back to the building is now it's completed and you can see what it is that we've been designing. It's fantastic to come here and actually look out over the rest of the City of London and actually start to see some of the other buildings that I've done over my career. And even in this sort of small panorama going around here, I can see 5 or 6 buildings which I've actually had a very significant input into. So it's a great city and it's a great building.
Now we're in 2015. It's over 13 years since that first phone call and the competition that kicked off the Leadenhall building. And it's been on and off. We've been going very fast at times, we've been going very slow at times. But it's always been there in my life professionally for that period of time. And in the group of people I work with, we've kind of kept an amazing continuity of team through the whole project, and it's great now for that team to enjoy the physical manifestation of all that work that is the Leadenhall building.